Okay, I see a lot of familiar faces. I see a lot of new faces. So I want to make sure that tonight's talk is useful for everybody, which means that it probably will be less useful for the people who have been building the ecosystem for a year. But I hope that those people appreciate the value of making something that everybody can understand. So maybe whenever you ask people to raise their hands, nobody raises their hands. But let's assume everybody's equal with that. How many people are developers in general in the audience? A few, okay. How many have developed in Cairo? Okay, a lot of Cairo developers. How many have not developed in Cairo? And for how many people is this your first like Starknet event or side event or? Okay, there are enough people to see your first Starknet event. Okay, so I'll keep the level of the content to you. There are a dozen hands are raised, so I assume there's like 3 dozen people, including the people who didn't raise their hands. I'll try and make it like 15 minutes and then like 5-10 minutes of questions. And again, it might be a bit of revision for others. I think it's worth it. So I am Liron. I'm the head of business development at Starkware. It's also worth reiterating that this Starkware is the like equity entity where there are developers and engineers and product managers who build software. Some of the software we build is for the Starknet stack or the ecosystem and the infrastructure there. There's also a Starknet Foundation. It's a separate entity. I'm coming from Starkware. So I'll just want to talk about Starknet, the technology, the roadmap, the ecosystem. The slides are a bit out of order. For the people who raise their hands and don't even know about Starknet, are you familiar with like why ZK rollups are the future? Or should I explain about why ZK rollups are? We can work on that assumption. Okay, great. There's never a dumb question, really. So yeah, Starknet. This is just a slide we took. We got like to TPS close to 50, roughly 2 weeks ago. It's just showing the potential of the technology. The basic idea is to have Ethereum security with at least 100x the TPS of Ethereum. That's my words, at least, don't quote me. And at least 100x cheaper than Ethereum. Again, my numbers, don't quote me there. But I think that with the reasonable assumptions and engineering work, we should be able to get there. Jumping straight into features that exist. So account abstraction, who's like, so Ethereum has this EIP 4337, and that's basically having account abstraction not at the protocol level, but a layer on top of the protocol. The people who've this like the 15th Starknet event, you're like, oh, I have to hear about account abstraction again. But to those who are new, it's a really valuable proposition. Basically, every single wallet on Starknet is also a smart contract. It's a deployed smart contract. So you have all the functionalities that you have in a smart contract you have in wallet by default at the protocol level. This basically, on a technical level, you have 2 stages whenever a transaction is submitted. You have a validation function and an execution function. Now, the validation function is completely up to you what logic you have there. You could have a traditional elliptic curve digital signature. You could have, like, some teams have developed the Face ID on your phone unlocking triggers a transaction. You could have session keys. You open up a key, you play a game for the next half an hour. Any transaction you submit from your address in that half an hour don't require signing because the validate function allowed that. It really unlocks, again, this is very cliche, but unlocks the blockchain to the wider world. So Web 2 users who don't want to manage private keys, they don't want to manage seed phrases, can now come and use Starknet. This has nothing to do with being a ZK rollup technology, right? It's got to do with the design of the blockchain. Another important thing, this is like probably those sitting in the audience for your first Starknet event, you're like, why Cairo? You hear this? This just skipped. Right, like why can't we just have Solidity contracts? And a lot of the other teams in the space who we highly respect have opted for more like what's called the ZK EVM. And there are 4 different types of ZK EVMs, and that's a whole lecture in and of itself, quite a technical lecture actually. There's this question, do you want to optimize for the existing EVM ecosystem, developers who can write in Solidity, or you want to come and take the other direction and say, let's write code that is optimized for the Stark proofs that we're generating. Some people this is like a 45-minute discussion that I'm giving a 1-minute capture of. That's the core trade-off that we have here. We believe that having a domain-specific language like Cairo really helps you in terms of the performance of the network. And with Cairo, right, especially with Cairo 1, it's a very Rust-like language. And I highly encourage you to look at the resources online to try it yourself if you've never learned Cairo. I've done Starklings, I've done my own fair share of it. It is really it's a very high-level language. Unlike Cairo 0, the previous version, which gets like basically no assembly and like very detailed stuff about memory management, etc. So that's basically the thing with Cairo. Another thing worth mentioning is also the objective numbers in production. So we see it in production, not just like academic theory or tweets. Using Cairo, we're on StarkX at least, minting NFTs for 50 gas, which would cost like 60,000, 70,000 gas on layer 1. Or DYDX trades on layer 1 would be 200,000 gas and like 500 gas on using layer 2. So we just think it's worth, like, as a developer, it's worth a few weeks of investment to learn a language like Cairo and then be active in the ecosystem. Another point I'll say about Cairo is every developer in the Starknet ecosystem has basically made an active decision to say, I'm learning Cairo in order to be part of the Starknet ecosystem. In contrast, teams that have written Solidity code who just go to multi-chain and deploy on every EVM chain, they're not necessarily committed to that latest EVM chain they deployed on. They're like Solidity interested. So, and again, I'm not trashing that. I'm just saying that what you have with Starknet is a vibrant ecosystem of like Cairo developers who are super committed to the ecosystem, which is a nice thing. What else can I share? Oh, the roadmap. This is probably worth speaking up for a bit. We are in mainnet alpha. We are in mainnet. We're submitting proofs. Actually, the 0.12.2 was out on mainnet last week. The big thing happening in the next few months, the first thing is volition. Who here does not know volition Validium? It's okay to put your hand up. One guy, okay. A few hands are coming up. I assume that means that there are, again, a dozen hands that are not up. So I will send them in on this, and others will forgive me. There are two things basically sent to Ethereum with Starknet. You send the ZK proof, but the proof is not sufficient. In addition to the proof, you also need to know the state of the network. An analogy I like to use is you can tell your friend that x equals x, but separately you need to tell them what x equals 5. So too with us, like with DYDX trades on StarkX, you send a proof with all the transactions. You still need to know that Liron has $1 million USDC after all of those trades. So you send two things, the state update and the proof. The state update, you can send it all on-chain, which means you have this massive Merkle tree of all the balances. Expensive gas, right? Because you're sending the state on-chain. Another option is what's called Validium, which means you don't send the whole tree on-chain, you send just the Merkle root of that tree. Now, if you send the Merkle root versus the whole tree, you have significant gas savings. I can talk about this for like 5 hours. Because even with the on-chain, if you do the roll-up mode, the first data availability mode where the whole tree's on-chain, you can do this clever thing where you only do the differences in the tree between proofs, right? But Validium, when you only have the root, you save all of that gas, and this has significant. It depends on the type of transaction and what you're doing. Like up to like 90% reductions in gas savings, in addition to like using the proofs already. So by using Volition instead of Validium instead of on-chain data, you save gas. Volition is just the name for choosing between Validium and rollup mode, because the chain will be able to support both, and you'll be able to choose which transactions on each one. So that I think Q4 October they're talking about testnet for that, and we think once there's a mainnet, there are a lot of like use cases where that becomes more and more affordable, which we're very excited for. And then there's a lot of stuff on the roadmap. Again, for those who are familiar, it's great. For those who are not familiar, it's not. Like fee markets. So most L2s to date just have a first in, first out sort of centralized sequencer, and you trust them. And the fee that they pay is based on a fixed formula. It's not based on congestion. This is critical for any decentralized network. And then you have Paymaster in version 0.15. Paymaster basically allows you to pay your transaction fees in any token that you like. So you have USDC or something, you pay in USDC, and you don't need the native token to pay your fees. Behind the scenes, it's taken care of. What's not on this roadmap? Like, decentralized sequences are still a while away. There's a lot, in order to make a performant and stable network, there are things you do first, like these sort of things. Cool. Let's see what else to talk about. I'm trying to see. There's this is all just like a shilling stock net, but I really want to keep it to interesting stuff. I'm using this just to talk about terminology. Ethereum, you know, so I just want to like really make sure everybody in the room understands that. So StarkX is our app is a Starkware powered app chain service. So it's not like a decentralized open network. You call Starkware, the biz dev team, we like talk to each other, we sign a legal contract, we spin up an app chain for you. It's good in cases where that makes sense. There are other app chains on the Starknet front, which we'll get to in a slide or two. Cairo, we talked about. Sharp. This is also something worth talking to the people new to the group. Roughly speaking, it's the same amount of Ethereum gas to verify a proof, regardless of the size of the proof. I know I'm oversimplifying that, but given that the computation in the proof is so big anyway, the marginal cost of verifying a proof, if more transactions are in it, are pretty negligible. So if I'm anyway submitting a proof, I'm very happy for you to add your own transactions to my proof, and that will reduce the gas costs per transaction. So we have the shared prover technology, which shares proofs between app chains and the public network. It's very, very cool technology. Starknet we talked about. Recursion is something that happens right now. It's off-chain. You basically verify proofs of verifications of proofs, etc. So you condense things more and saves on gas. And layer 3. Layer 3 is probably something we're talking about for a second. And then we'll go to questions. Okay, yeah. So basically, like, you imagine you have. Not imagine. You have layer 1 Ethereum on the base. There's a smart contract there. They can verify stocks. And then on the public network, you have the shared prover. I just talked about this. So you'll have public Starknet, some other app chains using the same shared prover, sending a single proof to the verifier. And then you can basically have that same architecture. Yeah, all those people can benefit from Cairo, the volition data availability, account abstraction native to the protocol, etc. These are just the same points. Yeah, an app chain basically, I think you guys know the trade-offs pretty well. Like, you're not connected to the public network, so you don't have composability, but you have the control of the network yourself. But then, this wasn't really explaining layer 3. Layer 3 basically says, in addition to having layer 2, you can have a layer 3 app chain now, and there's a verifier contract on layer 2, and the proof gets submitted from layer 3 to layer 2. You could just do that exponentially. Why do you do that? You can reduce your gas costs, better UX, all the infrastructure that works with the public network should hopefully work for an app chain. So you can use the same wallets, the same API services that's spun up for their own app chain. It's a very elegant architecture. I think I'll leave it for questions. Anybody have questions or comments? Oh, sure.
About the paymaster, can we have something like we can sponsor the gas for the users? Like they don't have any tokens in their wallet.
Yep. So the question was whether you can sponsor gas for users, and if you have Paymaster, and the answer is yes. So for example, I want to buy an NFT, and the app says I will cover the gas cost of that NFT. Paymaster enables that. How? That's great. Yeah, yeah. Other stuff to tell you, I don't know. I've been. It's a very vibrant ecosystem. We would not put it this way. With the Starknet is too big now for to be fully dependent on Starkware. We're very reliant on people in the ecosystem like you, specific teams building important stuff. It's a decentralized network on the social layer, on the engineering layer, on the app layer, on many different layers, and it's something very exciting to watch. And I've sort of seen that transition from like 2 years ago to today. Yeah.
Yeah, I have a question about the last slide, and the topic that you said you can spawn multiple LPs
Yeah.
on top of L2. And here's the thing, the question is about more than 50% attack. It's sort of like you create multiple
Good. So I'll repeat the question for the video and for those who are couldn't hear. He asked if we have like hundreds of different L3s, aren't you fragmenting the security basically? If you need people to stake or just nodes to be running on each different app chain. Now, ignoring the question of whether each app chain is running decentralized or centralized, the security comes from the proof being submitted to L2 and eventually to L1. It's unlike optimistic rollups where there's economic security. Here there's cryptographic security. So you might have, assuming the proof actually reaches a layer where you sufficiently trust the security of that layer, that's where your security comes from. So like there's no withdrawal delays. For example, when you until you submit the proof, there's a withdrawal delay. Once the proof is there, you're good. So that is I think that answers your question. Meaning, as long as you're happy to be submitting proofs, your security comes the second that the proof comes. Yep. Components? Okay, the product managers were telling me like 2 weeks ago. So I need to check internally. It might be, unless somebody else knows, but it should be a week or two away. I don't know, but I need to check. Other comments and stuff. Where to get started? You go to starknet.io. You follow the resources there. There's some really good community managed resources. I'm always scared to say names of individual resources because then I don't say other resources. So if you go to the starknet.io, there's a link to the documentation, to the Cairo book, Starknet book. It's really good to start with that. Yeah. Any other questions or most of you are developers, right? Silence. Okay, cool. I will give it 10 more seconds for more questions. Otherwise, I'll stop. Yep. Oh, how many smart contracts are deployed on mainnet? So we know the answer to that. I think I'm roughly 2.3 million. I think if somebody using Cairo 1 or Cairo 0. There's a dashboard that I can pull up. I think there's people are still using Cairo 0 for deployment until the regenesis happens. And I think it's roughly 2.3 million. Now that might include, I'll confirm the numbers after the talk. I don't want to say numbers that are wrong. So which specific change? The 4844 or? Oh. Interesting. Okay, so he's asking a very specific question about if the data structures on Ethereum move from like a Merkle to Merkle Patricia. Merkle to Merkle. I don't think Tomasz is saying it's not going to make a difference. If anything, it's like any other smart contract that's already deployed. You're welcome to use those data structures, but it doesn't affect existing smart contracts. Like other stuff's worth mentioning. Even 4844 will make data availability costs significantly cheaper for L2s. So it's good for optimistic rollups, for ZK rollups, for everybody. But I think like at the end of the day, this blockchain trilemma, getting scalability and high throughput, you're not going to have without layer 2s. Okay, another interesting question about optimizing the hardware. I assume for proof generation, you mean? I actually got asked this question today at a panel. There are teams working on that. There are lower-hanging fruits. So we currently use these big finite fields. You can move to smaller finite fields with like 32 bits or 8 bits even, and that gives improvements. You can move to a different hash function, and that gives different improvements. And there's no point like optimizing the hardware for a specific hash function if like 6 months later you move to another one. So they're all in the research phase.
Also, like, this is the final question. So, like, obviously, Starknet doesn't go with the ZK-SNARK approach, and mainly ZK-SNARKs are based on bilinear pairings and
Yep.
discrete log problems, but inherently they are not quantum resistant. Starks are quantum resistant, but I don't think they are fully post-quantum because they don't rely on lattice cryptography or something like that, which will never be beaten by a quantum computer. So, has Starknet thought about research?
So the question was whether we've thought about if quantum computers come and able to crack certain hash functions and security. Yeah.
Quantum resistant for now because we can assume that the quantum computers built for now may not crack it, but eventually we don't really know, right?
So the when I speak to Eli Bentasson, our co-founder, about this, I ask him these questions. He says you can always just move to a different hash function that is quantum resistant or harder to crack by quantum computers, and that's orthogonal to the protocol. Meaning it's a parameter that you choose in how you implement the Starks.
Consider moving to Kyber or Dilithium.
Yeah, I don't think we're there yet. I think if there are quantum quantum computers manage to do this, we have bigger problems in the world, and I don't think that. Yeah, I think there are higher priority stuff like getting volition and decentralizing the sequencer. Yeah, cool. Great, we'll end there. Thank you.